So, today's lesson in Foundations of Math 10 is 3.2, and we're talking about perfect squares, perfect cubes, and their roots. Okay, three things we're going to deal with today. Now, hopefully you've heard about squares, you've heard about cubes, and you've heard about roots. Hopefully you have some knowledge of this already. But just in case you don't, let's start from the very beginning. All right, this diagram right here is a square. I know it's kind of freehand, it doesn't really look like it, but let's assume that all of these are 90-degree angles, and all the sides are the same length. So a square is a figure, a closed figure with four sides. They are all the same length, and at all of their intersections, they form a 90-degree angle. Okay, you know that, but that's sort of the definition. Here's another square. Freehand, I apologize, but it's a square. Now this one, this little one, has a side length of 2, to just arbitrarily put that side length there. So 2. Now, what is the area of this square? Do you remember how to find area of a square? It's 2 squared, or 2 times 2. Now, if it's a square or if it's a rectangle, that's where all the sides aren't equal, but maybe these ones are equal, right, and then these ones are equal. You do length times width, right? So you do the same thing for a square, and it just so happens, you're absolutely correct, that the area is 2 squared. Now that's kind of cool that this is squared and that the shape is a square, isn't it? All right, that is kind of cool. I mean, that's teacher cool, that's not student cool. I get it. It's not like cool on a Friday night cool, but it's cool in a classroom cool, okay? So just let me be. Now, what is the area? 2 squared is equal to what? How can I rewrite that? What's 2 squared? 4, right? Okay, so that's important. That's going to be important. And guess what? We have this over here, right? You saw that. All right, so this one right here, where we have a square side length 5, what's the area of this square? 25, right? 5 times 5 is 25, okay? So 25 is actually 5 squared. 16 is what? 4 squared. 9 is 3 squared. 36 is, okay, you guys are getting it, right? So there's a connection between a number times itself and squares, right? And so when we talk about perfect squares, you know what we're talking about? We're talking about these numbers right here. These are perfect square numbers. The reason is because they represent the area of a perfect square, of a square. These are all areas. Now, is 100 a perfect square? Anyone know offhand? Is there a number, like a whole number, where you can multiply by itself to get 100? Yeah, what is it? 10 squared. Okay? All right, now, what I want you guys to do, we got 2, 3, 4, 5, 6. Okay, well, 7 squared is 49. 8 squared is 64. 9 squared is 81. Okay? You guys should know that. What you also should know is you should know 11 squared and 12 squared all the way up to 20 squared. So I'm going to give you a second right now. I want you to put that in your margins. I want all the way from 2 to 20 on your paper. Okay? If you need a calculator, that's no problem, but I'm going to expect you to kind of recognize these perfect squares up to 20. All right? So take a moment and do that. All right, so those perfect squares from 2 squared all the way to 20 squared, I really would like you to memorize them as much as possible because, you know, when you're doing math, if you have to go to your calculator to do 8 times 8, if you really have to go to your calculator to do 8 times 8, your homework is going to take you twice as long, okay, 3 times as long, and you're going to get flustered on a test. You know, if you have this stuff, because, you know, you think about it in any any sport or any activity that you do with this instrument or whatever, the more you practice and the more you can do automatically, A, the fewer mistakes you're going to make, B, it leaves so much more processing power for your brain to do the other deeper things, right? And to understand and to be able to react and all that sort of stuff. So if I have to think about dribbling in a basketball game, if I have to think about actually down, up, okay, don't mess this up, I'm not going to play basketball very well, right? And you guys are basketball players, a lot of you. You know that you just do that without thinking. So in math, okay, I want you to try to go over this, to practice this, okay? And try and get this as automatic as possible, all right? Because literally, it will help you out. Now, do you need to know that 13 squared is 169 in everyday regular life? No, but when you're doing your homework, in this section, it's going to help you get it done quicker. You'll make fewer mistakes. Okay, there's my little sermon for the day. Now, I want to talk about roots here now, okay? Roots. Roots, if we take a look at this statement right here, 16 equals 4 squared, okay? 16 is a perfect square because I have a whole number here that I am squaring. It makes sense. So this right here, 16, is the perfect square. So we call that perfect square. And the 4 is the root, okay, or the square root. Okay? 16 is the perfect square, 4 is the square root. And if we move over here to the notes, the square root sign, I think you've all seen that before. The square root sign. What that means is that we are going to find out what number is multiplied by itself to get the number underneath. Okay? It's different than a dividing sign, right? So this would be a dividing sign like that, okay? You'd have some number in here and you'd have some number outside. That's a division question, dividing sign right here. That's not what we're talking about. We're talking about a square root. So the square root of 64 is 8 because 8 squared equals 64. All right? So if you look on your calculator, you will find that you'll have a squared function. Most of your calculators will. And the second function that's related to that is the square root. So look over here on my calculator. You see this? That's squared. What's the opposite operation? Look at that. The second function is square root. Okay? That's how they're related. All right. Okay, so here's the list, and I'll just zoom in on this a little bit here, but this is the list of perfect squares for the numbers for 1 to 30. Now, 1 to 20, I just mentioned that you need to kind of have those memorized as best as possible you can, but obviously there are perfect squares that are a lot larger than that. Oh yeah, it's indoor recess, everyone. Good job. Okay, don't be running outside in your bare feet. Okay, so here's another way to look at perfect squares and their roots. Look at this. So the square root of 4 is 2, because 2 squared equals 4. The square root of 196 is 14. The square root of 576 is 24. And that's because 24 times itself equals 576. Are we all on the same page here? Yeah, pretty easy. Okay, I'm droning on, and I really don't need to. Okay, that's good to know. All right, so let's move on then. Perfect cubes. Let's talk about perfect cubes. Now, you know what a cube is, right? A cube is a three-dimensional box, right? But not only is it a three-dimensional box, it's a special three-dimensional box. And what's special about it is that all of the faces are squares. And they're all squares that are identical. They're identical squares. So every dimension on a cube is the same length. Okay, this bottom part here, and the height of it, and the depth of it, okay, the back side, the top, everything. It's all the same. That's what a perfect cube is. Now, there are some perfect cube numbers as well as perfect square numbers. Perfect cube numbers, like 8, is a perfect cube because you can take the same whole number and multiply it by itself 3 times, and thinking 3 and writing 3, and it's supposed to be a 2. But if you were to find the volume of this perfect cube, you remember from math and from science that the volume of a cube, right, is length times width times height. And if length times width times height are all equal to each other, and let's just call it the side length here, that's the same as cubing the side length. 2 times 2 times 2 is 8. Therefore, 8 is a perfect cube. Here are some other perfect cubes on the right. 27 is a perfect cube. Why is that? What number am I cubing to get 27? 9. Okay, 9. Do you think that makes sense? 9. Now remember what cubing is. 9 times 9 times 9. So does that look right? No. But thank you for saying that. We learn so much more when we get an incorrect answer than when everything gets correct. Okay, so thank you for that. But it's not 9 actually. But you're on the right track, right? It's 9 times 3. But what is 9 made up of? 9 is made up of 3 times 3. So yes, it is 3 cubed. Okay? And a lot of people get that mixed up. So you won't get that mixed up now, right? Because when we do this power here, it's not 2 times 3. Remember, this is 2 times 2 times 2. So this is 3 times 3 times 3. All right, so what's the next one here? If you look at, there's a bit of a pattern. 64 is a perfect cube, and that is 4 cubed. That's 4 times 4 times 4. What is 5 cubed? Anybody know? 125. Very good. 125. Okay. Very good. All right, so you kind of get the idea, and there are many more perfect cubes as we go along. I won't make you memorize all 20 perfect cubes. Okay, those get pretty large. But 10 cubed is an important one to know. Do you know what 10 cubed is? 10 to the power of 3. 10 times 10 is 100 times another 10 is 1,000. Yeah, that's an important one to know. You have to know that one. Okay, so that's 10 times 10 times 10. All right. Now, over here, if we look over here, I don't know if you notice this part over here, but we have some notation as well that we have to know for perfect cubes. So, do you notice that we have a 3 in here? That's a square root sign, but it has a 3 there. So this is actually a cubed root sign. Okay? Cubed root sign. So what it's asking us, or what it's requiring of us here is, hey, is there a number that you can multiply by itself 3 times to get 8? And of course you know that that's 2, right? This is saying, is there a number when multiplied by itself 3 times gives us 125? And you know that that's 5. Okay? So what's the cubed root? And you do have to put the 3 in there, because if you don't put the 3, it's actually a square root. So what's the cubed root of 64, guys? 4. Very good. All right. All right, you're on the right track here. Now, just for future reference here, I just want to tell you what kind of each of these are called. So here's an example. It's in your textbook, actually. I'm just going to erase a few things here. Give myself some room. So in this here, this whole thing, if you see a radical or root sign, sorry, it's called a radical. Okay, that whole term is called a radical. Have you ever heard that name before in science or in math? Radical. Okay, so that is a radical. Now, this right here is the radical sign. So, whoops, wow, what is that word? I don't know. Radical sign. It's kind of emergency downstairs. All right, this number right here is the index. The index of the root. Okay, so that's the index. And consequently, if there is no number shown there, what is the index? What's the value of the index if there's no number shown there? 2, yes. Square root. Okay, very good. So you could have a cubed root, you could have a 4th root, 5th root, 6th root. So you could have any number in here, any whole number in here. All right, this number finally underneath here, I'll put that in maybe a different color now. This number here is called the radicand. So if I'm talking about something and I say the radicand, now you know which number I'm talking about, right? Okay, so that's just some terminology. We're going to go back to some prime factorization. So if we look over here, and you take 196. Okay, now is 196 a perfect square or a perfect cube? Look on your list there. What is it? 14. Okay. So now I'm going to show you. I'm going to show you how prime factorization, okay, will show us that this is 14. Right. So how do we use prime factorization? That's what I'm doing now. So use prime factorization to determine if a number is a perfect square or cube. That's what the title of this little example is going to be. Is a perfect square or cube. And I'm going to do this one first, and I'll do one that's a different example. All right, so if we prime factor this, can I divide this by 2? Well, it's even, so I can divide it by 2. So what's this divided by 2? 98. What's 98 divided by 2? 49. What's 49? Oh, can I divide that by 2? No, I can't. What's a prime number that I can divide 49 by? 7, and that gives us 7, and we're done. We're done factoring this, right? So what I want you to notice is that the product of these here, okay, you can write this as 2 times 7, so one of these and one of these, times 2 times 7. See that? Equals 196. So this is actually 14 times 14. See that? So 14 is the square root, because I've determined that I'm multiplying it by itself. So how do we determine that from a list of prime factors? This is how right here, and I want you to write this down. Over here. Not sure why that's off the screen. But a perfect square number will have exactly 2 groups of identical factors in its prime factor list. So just copy that down to your notes. So in this case, we found that there are 2 identical sets, right? We've got a 2 and a 7, and another 2 and 7, see? 2 identical groups. And that works for all of them, all of the perfect squares. What about perfect cubes? How does it look for a perfect cube number? Well, 512 is a perfect cube number. So what's 512 divided by 2? 256. What's 256 divided by 2? Divide that by 2. 128. Very good. What's 128 divided by 2? 64. What's 64 divided by 2? Good. Let's go on. Now, can I divide 32 by 2? Yep. That's 16. Look at this. A whole bunch of 2's here. All right. So that's our prime factor list there for 512. Let me write that out for you. That actually is, how many 2's there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 2 times 2 times 2. 9. So that's the list written out. A perfect cube, what you have to remember is a perfect cube is a number that has another number multiplied by itself 3 times. So when something is multiplied by itself 3 times, we want to see the same thing multiplied 3 times. So I have, look what happens if I do this. 2 times 2 times 2 is 8, right? And if you notice, I actually have 3 identical groups of 8. So if I take 8 cubed, what does that equal? Well, let's just double check here. 8. So on your calculator, you may have a power button that looks like this. That's my to the power of button. You may not have a cubed or a perfect to the power of 3 button, so you might have to do that. Look at that, 512. So a very similar rule exists for perfect cubes when you're looking at the prime factor list. And that rule is right here. So write this one down as well. I'm just going to bring that up for you. It says if a number has exactly 3 identical groups of factors, then it is a perfect cube number. So the question that you'll see in your assignment, it'll say use factoring to determine whether each number is a perfect square, a perfect cube, or neither. So if you can't break down all the factors in this way, it's not a perfect cube. If you can't break down the factors in exactly 2 identical groups, it's not a perfect square. If there's another number hanging out over here, then it's neither. Okay? All right? Any questions? Pretty straightforward so far. Okay, here is your assignment right here, and I want you to copy that down.